Okay, welcome back to my channel, Master Tutorials. We see where mathematical literacy begins. This is Master Tutorials Online Mathematics class. Okay, in fact, I did a previous video that's variable coefficient under ordinary differential equation. I forgot to input my hi my adapter into the phone so that you can hear me when I speak. And I was doing the video. Charlie, about let's say is it 17 minutes to 20 minutes video. Imagine I'm nine so a video. I'm done now. Before I did that, I didn't hear like as in a proper sound. It's like the normal sound. I was like, hey, and I didn't see all these things. And yes, but still I'll post it. So if you see that video, please put earpiece inside your ears and listen. Then get closer. Pay rapt attention to the video I was doing. I beg you. And yes, I party. I want Mr. Remo. All right, so let's see another um thing here under ordinary differential equation. We are looking at solution to second order homogeneous differential equation. Second order homogeneous differential equation. Now, it's second order because we have two here. Second order. This one is one, that's first order. So don't forget, second order, first order is inside second order. Now, again, why do we say that it is homogeneous? When it is equal to zero, it is homogeneous. When the right hand side is zero, it is homogeneous. And also, when it involves numbers, we call it constant coefficient. So there is a number here, -2. Also, there's a number here that's, let's say, 1. Okay? So it is called what? Constant coefficient. Now, we have three cases. The first case, which is two distinct roots. Now, the solution we'll get what? Two distinct or different roots, which can also be called what? Real roots. Okay, all right. So these real roots, when you plot it on the Cartesian plane, these two roots, they cut the x-axis. That means they are two distinct roots. So let's see how best we can solve this differential equation. So let's see solution here. First and foremost, we say that let the solution, which is y, to be equal to e exponent rt. Okay, and because we are dealing with second order, we'll be differentiating this y with respect to t 2 times. So we'll get y prime, that's the first derivative. How do we differentiate an exponential function? We differentiate the power, which is rt. When you differentiate rt, it is exponent 1. So when it comes down, we'll get 1 times r, then t exponent, we subtract 1. So we get r t exponent 1, 0. So it's still r. So which means when we get r, we use the r to multiply the exponential function again. So we get r e exponent rt. So this is what we have. Okay. Now, the same thing, we have to take the second derivative of this guy. The same thing, how do we differentiate? RT, we get what? R. So the R will multiply this R. Then we get R squared E exponent RT. So this is what we have. So the first order, second order. But I said, don't forget when you start, you let the solution y to be equal to E exponent RT, y prime equals r e exponent rt, y prime prime equals r squared e exponent rt. Now we substitute all these into the equation over there. So we are coming to do substitution. We have the equation to be y prime prime plus y prime minus 2y equals 0. So let's substitute. What is y prime prime? Y prime prime is r squared e exponent rt plus y prime is r e exponent rt minus 2. What is y? Y is what? Um, e exponent rt equals 0. So we do substitution. R squared e exponent rt plus r e exponent rt minus 2 ert. So that's what we have. Very simple. Okay. Now, don't forget we have e exponent rt, e exponent rt, we have e exponent rt. We can factorize it out. So e exponent rt. Then what do we have? We have r squared plus r minus 2. That must be equal to 0. Now, but our e exponent rt can never be equal to 0. It can never be equal to 0. Why? Because when we put in even 0 here, let's say r is 0, t is 0, it will be e exponent 0, and e exponent 0 is 1. There's no 0. So it can never be equal to 0. So r squared plus r minus 2 is equal to 0. So this can be equal to 0. That's a quadratic equation. R squared plus r minus 2 is equal to 0. So we can solve this quadratic equation. We have three methods in solving quadratic equation. By the method of what? Factorization, by using the quadratic formula, by using the method of completing squares. So we can solve this. So I have my calculator here. When I punch it on the calculator, I don't want to stress my mind. So when I punch it on the calculator, let's see, I have one, positive 1, negative 2. So the roots are is a 1, then negative 2. So which means I have r squared plus, let's say r. No, this one will be 2r, then minus r minus 2 equals 0. Why? Because 2r minus r is positive r. So I put that in bracket. Okay, in bracket. So I factorize r out. I'll get r plus 2. Then here minus 1 out. Then I'll get r plus 2. Don't forget negative, negative. You get positive 0. Positive answer or positive sign. Sorry. Now this and that are the same. So we have r plus 2. Then r minus 1 equals 0. You can factorize r plus 2 out. So when you factorize it out, you get r minus 1 is equal to 0. Okay, so from here, we can use the now property. R plus 2 is equal to 0. So r plus 2 is equal to 0. R minus 1 is equal to 0. We have r equals negative 2. R equals positive 1. So this is what we have. Let me divide the board so that we get more space to solve this. Now we have r which is negative 2, r which is 1. When you draw the number line, negative 2, then 1, which means from the lowest to the highest. So negative 2 comes first. So this will be our solution here. Don't forget you said let's y is equal to e exponent rt. So I have y, that's the first y1, which is equal to e exponent, our r is what? Negative 2. So negative 2t. Then our y2, which is equal to, that's we get e exponent t. We get e exponent t. So this is what we have for y1 and y2. All right. Okay. So if you want the general solution, so we have the two solutions. So therefore the general solution is equal to, that's y of t must be equal to, that's c1 e exponent negative 2t plus c2 e exponent t, where c1 and c2 can be known or can be found. Okay. So C1 and C2 can be what? Can be known or can be found. So all these are C1 and C2 are variables, so we can find it. Okay. All right. So let's see the next example. So if you don't understand, please play back the video for better understanding. See you in our next video. Bye bye.